Hello, this is MFM2PI, our fifth unit trigonometry, lesson number 3, the primary trig ratios. So the objective of the lesson today is to learn how to express the three primary trig ratios in their lowest fraction form. So there's going to be a whole bunch of new learning today, but we're going to start with a quick reminder of what a ratio is. So as you can see here in the note, a ratio is a relationship between two values of the same type. So one example of this would be number of girls and number of boys in our current math class. And they're of the same type in that they're both people, but we can subdivide it into sort of two parts of those people. Girl part, boy part. So if we consider the 24 students in our class, 9 of our students are girls and 15 of our students are boys. So this is a ratio, and you'll notice one way to identify a ratio is that it has a colon right here between them. So it's 9 to 15, and it doesn't need a unit because the unit is going to be the same. So we don't need to say it in this case, and that would be people. Another way to write a ratio, and this is what comes into play today in our lesson, another way to write a ratio is as a fraction, where our first term becomes the numerator in our fraction, and the second term becomes the denominator of our fraction. So if we were to use that same ratio of girls to boys, the ratio of girls to boys in our class would be 9 to 15. Or, if we were to write this in lowest fraction form, and here's a way to do it, is if you have your factor chart with you, you're going to look for the largest factor that is common to both 9 and 15. And in this case, that factor is 3. So if we divide both the numerator and the denominator by 3, we're going to arrive at an equivalent lowest form fraction, which in this case would be 3/5. So as I said, this is important. A, because we're going to be expressing our primary trig ratios today in fraction form, and it's always important to express those fractions in their lowest form possible, which means looking at the fraction you have and then reducing it using your factor tables. Okay, so let's get back to the real meat of the lesson, which is figuring out what exactly are these primary trig ratios. So we've been exploring triangles, and we've been exploring the three sides that our right angle triangles have: our hypotenuse, our opposite, and our adjacent. And there are ways of combining and comparing the sides of a right angle triangle so that we can have an understanding about how they relate to each other. And there are common ones. So these ones are called, the ones we're going to look at today are called the primary trigonometric ratios, which means, of course, that there are secondary trigonometric ratios, but we're only concerned with the primary trig ratios right now. And we are looking to identify particular relationships between the sides of right angle triangles from a reference angle. And that's an important thing to note as well, is we know that the reference angle dictates which side is opposite and which side is adjacent. So it has a role to play in determining what the primary trig ratios are. So here's the part that we're going to memorize and that we're going to sort of learn over the course of the unit. The sine ratio, pronounced like sine, like, hey, there's a stop sign. The sine ratio takes our opposite side and puts it over our hypotenuse. That's the first primary trig ratio. The next primary trig ratio is the cosine ratio, which takes the adjacent side and puts it over the hypotenuse in a fraction. And the final ratio, the tangent ratio, which takes the opposite side and puts it over the adjacent side. Now this is something that you're just going to have to memorize. Ideally on our cheat sheet, this is where we're going to have a chance to put this so that we can always have a reference. However, over the years, people have come up with mnemonic devices to help people remember this. And this is the mnemonic device that people use to remember the primary trig ratios, and specifically what the name of the trig ratio is and then which sides it speaks to. And the trig ratio mnemonic device is called SOHCAHTOA, which is sort of, I think is meant to have you try to remember this, because if you stub your toe, then you SOHCAHTOA. I've never necessarily understood how that pertains to math. Nonetheless, this is the trig ratio mnemonic device that we're going to use, and hopefully it helps you, and if it doesn't, then you can just write it out longhand. SOHCAHTOA. So how do we determine the trig ratios for a given right angle triangle? First thing you want to do is you are going to want to identify your reference angle. So in our example here, we have a triangle over here, and our reference angle is going to be angle T. So there's angle T, and as usual, I'm going to just shade in that corner there so I just remember who's who. The next thing I'm going to do, label all three sides from the reference angle with hypotenuse, opposite, and adjacent. So I'm going to pause, or I would like you to pause the video here, and I'd like you to label this triangle. When you've got it labeled, come on back, and we'll see how you did. Okay, let's see how the labeling went. For starters, our hypotenuse is across from our right angle, which will be right here. Our adjacent side will be right across from our reference angle. So there's our opposite, and the adjacent is what is left, which is right there. So we have labeled opposite, adjacent, and hypotenuse in our example triangle. And now we want to express our primary trig ratios, making sure that we indicate sine, cosine, and tangent of our reference angle, and then getting the right sides in that ratio. So let's start with the sine ratio. The sine ratio, in this case, we're going to start by just writing out sort of a template version of it, which is the sine, which we write to look like sin. The sine of our angle, which in this case is t, is equal to the opposite side of the triangle over the hypotenuse. And now just a quick look over there to see what those values are. The opposite value is 4. The hypotenuse is 5. So that means that the sine of angle t is equal to 4 over 5. So that is a fraction, and it happens to already be in lowest form, so that's as far as we need to go on this. I do want to make sure that we're noting that I'm not just writing sine equals 5 over 4. The reference angle right there is an important, it's a crucial part of this primary trig ratio equation. So I want to make sure that we're always referencing that angle when we're doing our primary trig ratios. Okay, let's jump over to the cosine ratio. And again, we'll write out sort of a template version. So the cosine or cos of angle t is equal to the adjacent side over the hypotenuse. Again, a quick little reference to our triangle. And our adjacent side is 3, and our hypotenuse is 5. So the cosine of angle t is equal to 3 over 5. And again, that is a fraction in lowest form. We've got a reference angle included in our primary trig expression or equation. So that one's all done. Let's try the last one, which is the tangent ratio. So the tangent, or the tan, of angle t is equal to the opposite side over the adjacent side. Now let's have a quick look over at our triangle. Our opposite side is 4. Our adjacent side is 3. So for us, the tangent of angle t equals 4 over 3. And again, this is a fraction in lowest term, and I've included my reference angle, so that one is finished too. So this is how you go about determining the primary trig ratios for a right angle triangle. We're going to do one more example together. We'll sort of get you to do some of them on your own, then we'll come back around and get over to that self-assessment. So let's get a look at our next triangle. Our next triangle over here is triangle EMJ or JME, and we are going to use angle M as our reference angle. So there's our, whoops, let's get a highlighter on there. There is our reference angle, and I'm going to color in that corner. And again, I'd like you to hit pause here so that you can label all three sides of our right angle triangle with hypotenuse, opposite, and adjacent. So hit pause, label it up. When you're done, come on back and we'll see how you did. Okay, you're back. Let's start with our hypotenuse, which is across from our right angle. We've got our opposite side, which is across from our reference angle, and we have our adjacent side, which is the only side that's left, or the one that's beside our reference angle. So we have our sides all labeled. Let's start with the sine ratio. So the sine ratio for angle M is equal to the opposite over the hypotenuse. And we're going to go back and have a quick look at our triangle and see what O and H are. So our O value is 3.6 and our H value is 5.4. Now this is a fraction, but it is not yet in lowest terms. So when we reduce this fraction to its lowest terms, we end up with 2 over 3, which is a fraction in lowest terms. So what I'd like you guys to do now is hit pause in the video, and I'd like you to go ahead and label the cosine ratio and the tangent ratio and get those happening. When you're all done, come on back and we'll see how you did on the cosine and the tangent ratio. Okay, you're back. Let's get a look at the cosine. So the cosine of angle M is equal to the adjacent side over the hypotenuse. The cosine of angle M is equal to 1.8 over 5.4, which is also a fraction, but not in lowest terms. So the cosine of angle M, when we reduce it, is going to be 1 over 3, which is a fraction now in lowest terms. Last but not least, the tangent ratio for angle M will be equal to the opposite side over the adjacent side, which in our triangle will be 3.6 over 1.8. When we reduce that, we have tan of angle M is equal to 2 over 1, which is, we can just write as 2. And that's how you determine the primary trig ratios for a right angle triangle. Hopefully the lesson made a lot of sense. If not, cycle back through and listen to it again. Then head on to your self-assessment, followed by your mastery test, and then you're on to lesson number 4.